So, do you want to identify Mars Analogue Site on Earth? So you are in right place. Well, hello, I'm Anuj Soni, head at the Department of Astrobiology, Spaceonova, and I'm your host today. And how are you doing, guys? I hope you all are absolutely great. And so just let me know, like, if you can hear me properly as well as you can see me properly. Just write down in the comment section and let me know that everything is going well. So we will begin. Just I'm waiting for the very first comment from your side. Just let me know I'm audible to you or not. So, meanwhile, you might wondered what analog site is, right? And how you can find one. So to answer how to identify Mars analog site, we have Mr. Shubham, who is senior research fellow in SAC, that is Space Application Center ISRO, and our guest scientist at Spaceonova. And here he already worked and published few papers on planetary analog studies, and he is also working on Perseverance rover uh, to data to understand its geology of the Jezero crater. So, Mr. Shivam, how are you?
Yes, I am fine. I hope everything is fine from your side also, Anuj.
Yeah, I'm absolutely great as well. So today we are going to talking about like how to identify Mars analog site. But first, please let us understand your journey first and what attracts you to towards the planetary and space exploration.
Yeah, you know, as children, we all admire space. We all admire night sky. Okay, in our childhood days, in uh, at the night or at the evening, we would used to look up at the sky and get fascinated and try to connect the stars with imaginary line. So people have started doing that beforehand and named and identified constellations, and also the periodicity of the stars and the celestial bodies, like the motion of the sun in the daytime, or the but the changing phase of the moon. This makes people curious, and I'm not outside of it. I was also get curious about these things. And also there is another point, I'm very curious about the natural phenomena of nature, the physical laws of nature. So when something fascinates you, it makes you curious. And the curiosity is the basic human nature. Okay. So as a species, we conquered world, we conquered our planet because humans were curious. So that gave Homo sapiens an extra mileage, I could say.
Yeah, right.
So and indeed, I was curious about space in general. I also already mentioned the fascinated about the natural phenomena, and from that you could say I took geology as my course, and eventually came to the domain of planetary science.
All right, all right. That's very interesting because I'm also from the geology background. So yeah, there are some sort of stories that I also, loved and choose my career as in the field of geology. So, anyways, so like I want to know what inspired you to become a planetary geologist and how were the initial days when you choose this field?
Uh, so you have to go a few years back, like 6 or 7 years. Okay, so just take it as a story to begin with. Like I mentioned about my uh, uh, knack to natural processes, and it all coiled up when I took geology as my major course. Okay, I was admitted to geology department of Presidency University, Kolkata, for my bachelor's degree, and completed my post graduation as well from there. And in post graduation studies, what we call the Master of Science degree, that has a curriculum called dissertation. So, in which you have to do a project work, um, that is nothing but a short term research work. Okay. This is done to orient the students in the domain of research, to orient them. So, how they can carry for research, they can, if anybody is willing to take research as career, then how they will pursue a particular problem, how to work on it, how to identify a problem. So like that. And in my dissertation I was fortunate that I worked about or worked on the impact, one of the impact prominent impact crater in India, that is in the Ramgarh crater in the Indian states of Rajasthan. But as you asked, that inspired me to become a planetary geologist. But I would rather say that I don't believe in this distinction between planetary geology and planetary science and
Yeah.
general geology, because Earth is nothing but a planet. Okay, so there shouldn't be any distinction. There, all the departments that taught geology today, that eventually they're turning to the Department of Earth and Planetary Science. Um, you will see in near future in every geology department in our country, in foreign states, they are trying that the every majority of the art science departments are changed to art and planetary science. In India, yes, we are in the beginning, so we took those things separately. But at the end of the day, I'm basically a geologist. Okay, just working on some aspects of Mars.
All right, all right, all right. So like what I understand from the geology is as well, it's like very fascinating subject, right? In terms of when we talk about some planetary stuff, like we always study and want to curious about like how these planets form, and whatever these mountains and volcanic that you see over there. You are very interesting, like when you find like what was the process of it, right? And you also like mentioned about impact crater, right? And I am just curious about how these related to this field of geology.
Yeah, uh, that's a very interesting question. Okay, so basically, impact craters are the most prominent geological feature found on the terrestrial planets. They're most prominent. So, I mean the rocky planets. Yeah. So, to make it simple, there are majorly two types of planets in our solar system. What you know. So, one of them, the first one, is like terrestrial planets, the rocky planets, like our Earth, Mars, Venus, and Mercury. But the other types are the gas giants. Okay, they're bigger planets and they have a huge column of atmosphere. So, like the Jupiter, the Saturn, Uranus, and Neptune. So we found impact craters on the rocky planets, as well as the rocky moons, as well as on the asteroids. Okay, so on our Earth's surface, there are about 150 like impact craters have been found till date. But on the surface of the moon and the nearest planetary neighbor, Mars, they have numerous craters. Numerous craters. So they are preserved there because the lack of the plate tectonic movement and lack of the weathering agent. In case of moon, moon lacks any atmosphere, so it is a completely airless body. So that's why there is no, I could say that weathering agent is present except from the cosmic bombardments. But on Mars, the atmosphere is there, and the weathering processes prevailed on past. But now I did not say that it has ceased, but the pace of which it is going. It's very smaller than that of our very Earth. Okay, so the impact craters are well preserved there.
Yeah.
So I'm mainly focusing on Moon and Mars because they have been well explored. Okay, because of their proximity from Earth. So coming to the point that impact craters are important in mainly four aspects. Okay, four aspects. Number one, they help us to study the subsurface of any planetary body. How? When an impact process happens, when some meteorite hits the surface of a planet, it excavates some of the material from the subsurface. Okay.
Right.
Based on the size, velocity, and the angle of which of the impact, uh, thi- this can come up with some material from the lower crustal depth. Not only lower crustal, from upper mantle or lower mantle, it can take some materials to the surface. Okay, as a form of ejecta. But naturally, what we see, mainly the upper crustal to lower crustal depth, the materials get excavated. So what we see in case of any impact craters on the wall, we see a inversion of static gravity. So this helps us to see the subsurface without digging them up or without touching them. So by only orbiter-based instrument that a satellite, you could map the subsurface of a planet. Isn't it fascinating? Okay. So secondly, uh, 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 there are another thing when a meteorite coming and hitting the surface. So by the force itself, by the collision force, the meteorite gets melted and the
Yeah.
material which it is carrying is got spread over the surface there. Okay, so then from that you can understand the chemistry of the bolide itself. Okay, that gives you um, some insight about the impactor itself, and which we can relate to the planet formation processes, because
Yeah.
majorly these impactors, these meteorites, they are coming from the asteroid belts. Okay, and these asteroids are thought to be the what we call the planetesimals. Okay, they are analog to the planetesimals, the protoplanets from where they collided and made up the bigger planets like our Earth. So this is very fascinating. And also coming for this point, I can add that this foreign objects, as I said, that these foreign objects can carry some important stuffs like what. From the Chandrayaan 1 mission, people have identified water on the surface of the moon, the exogenic water, like they said. So that term exogenic means, the term is that this exogenic water means the water is coming from the outside impactors. They are not present on the surface of the moon. They have been carried by some impact processes and spread over the surface. So there is a theory that um, all the life on all the water on the surface of Earth also, they came from similar kind of impact processes.
Right.
Okay, so I have covered the major 2 points why impact craters are important. And number three, there are another point that sort not number three, that's the last point. I have already mentioned about 3 points, like that they have covered mainly. They have been found on the terrestrial surface. They can help us to construct the stratigraphy by excavating materials from the lower crustal depth. Then they can carry the foreign objects. And last, the major thing, the why impact craters are important, like they can help us to identify the age of a planetary body. Okay.
Yeah.
There is a technique called crater size frequency distribution, uh, that based on which we can identify the relative age of a crater surface. So, like what I did in my dissertation, I tried to understand the mechanism, the structural aspects, and the mineralogical aspects of a terrestrial impact crater. Okay, as an analog to the impact cratering process itself. So then again, I would rather like to say that my journey in planetary science started with that study. Then,
ये सुनने में भी थोड़ा इंटरेस्टिंग लगता है लाइक कि किसी की लाइफ जो है इट इज स्टार्टेड फ्रॉम द क्रिएटर राइट सो बिकॉज लाइक आई यूजुअली नो अबाउट फ्यू थिंग्स दैट many people's inspired by different events like and ये आपकी लाइफ का एक इवेंट था कि like impact study of impact crater right so this is very nice to know about it right and like and this actually gives me a better understanding of like how we can actually understand the study of planetary science as well right कि like if जब आप space में जाते हो you always think about कि there are multiple planets right so it's quite nice that's why I want to ask like why planetary science is in high demand right now.
mm, okay, look, then I will start answering this question. Like when we started studying Earth, then the journey of the planetary science started. Okay, so this is quite new thing. The new thing that we started exploring different planetary bodies, but with the help of the primitive telescopes, people looked on the Earth and they formulated the paths of the planets and identified planets. Oh, okay, like Copernicus did, Galileo did then. But then, with the advancement of technology, new things man have observed and try to point them out and answer their occurrences and formations. But after 1960s, the scenario has changed. With the advancement of better technology, people needed communication and they tried to conquer space. Okay, the first satellite was sent by the then USSR. Okay, that was named Sputnik, and it was a communication satellite. The space sector, you could say that is mainly dominated by the communication studies. But we planetary scientists, geologists, planetary geologists, we looking for the different planetary bodies and our Earth also from a different perspective. Yeah. Nowadays, technology has advanced 1,000 miles. So I would rather say from where people have started the journey of space science as a whole, as almost every developed and developing countries has their own space research organization right of now, and India has ISRO, and Indian Space Research Organization. They mainly they were monitoring the Earth systems, but with the Chandrayaan mission, ISRO made a ban in planetary domain also. Okay. Then eventually the Mangalyaan mission happened, the Chandrayaan 2 happened, and recently the Chandrayaan 3 mission is on the pipeline. So there are huge scopes. And NASA is planning several missions every year. So recently for planetary, in recent future, you have heard about Artemis mission. So then they will try to I would like the term to use like the term that colonize moon. Okay, there's a construct a base station there. So, like this Perseverance mission, the Mars 2020 mission, which is carrying on the Martian surface. So, this is collecting sample. The sample will be taken back to Earth. So, there are all long-term missions and long-term projects. So, there are huge opportunity. I would like to suggest the young people who are thinking of taking space science as a whole, or I not like space science, a planetary science as their a career. So there are huge opportunity.
Wow. Wow, wow. It's like that's why it is like in high demand, because everybody was like pretty much fascinated to go into space and study, at least study something related to space, right? Um, it can be moon, it can be Mars, it can be Jupiter, and it can be the moons of these celestial bodies. So
Yeah,
yeah, that's very interesting. And even like I know, like planetary science is not just about like geology or the biology. It's more about its physics, the chemistry, and like even I know there are like certain laws which are also applicable once you are, conducting all these missions as well. So that means like there is already a space ethics and like planetary law, right? So already there, so it is like a highly interdisciplinary branch that we have to actually understand. Like as you already mentioned about all these stuff and all these things, so a very interesting fact about the geology is to study the past. When we are considering about the geology, so it is a very interesting fact that we can actually study the past, that is a paleoclimate or paleo environment, and how that actually help in your research.
yeah. um, that's very good to talk with a geologist. Okay, this is the main point talking to you. That so like in our subject, I would rather say that our subject, not mine, our subject geology, the basic goal is to reconstruct the history, okay, of our own planet or different planet, but um, based on which geology we are talking about. So we carry out research for that purpose only. Okay. You are seeing some structures on the field. First we map them. So then map the structures. Then identify the lithology and characterize the mineralogy. They're the main three parts you do. So why do you do that? We do it to reconstruct the stratigraphy. This is our main goal, the ultimate goal. So, you probably know that the subject geology has started with the philosophy that's called uniformitarianism. That is
Yeah,
the present is the key to the past.
exactly. The
So,
present is key to the past.
yeah. So that is not uh, this is true for the other planetary bodies too. Okay.
Hmm.
So, in case of other planets, the same principle also work because they govern by the same principles of the nature. Okay. So, thus the key of our study, as I mentioned, that to reconstruct the past and the reconstruction of the paleo environment and the paleo climate is the part of the process. Okay. Like I could give you an example like that. We study minerals, so all these minerals have some unique stability fields. Okay, they appear in the presence of a particular EH/pH condition, a particular temperature, a particular amount of water availability. So, knowing the occurrence of a mineral in any geological setting, that will help us reconstruct the value environment. Okay, so to know the let's talk in fun terms that the work of a geologist is like work of some detectives. Okay. What do a
Yeah.
detective does? When a offender commits some crime. A detective goes to the spot, and he or she looking for the clues. Okay, to recreate the crime, like we geologists do, we go to the field and looking for the clue to recreate the past history. What our planet has suffered or it observed, and everything is recorded in the rock layers. Everything.
Right.
So, like that, from that study, the journey of reconstructing paleo environment, paleoclimate, and as a whole, the paleogeology, the geological history that started, and we do like that.
Yeah. Oh, what a nice analogy that you just made about the criminal case as well as the geology at the same time. Because like जब भी आप एक रॉक स्ट्रेटा को देखते हो तो you always feel like okay ये layer कैसे बनी होगी? What was the deposition at that time? What was the scenario at that time? That's pretty awesome, and that's why like geology, the beauty of geology is always there, right? And after that, like I also want to know like about like I remember one thing, right, in terms of planetary geology. So I remember one image that is actually captured by Perseverance rover, right? And it was in the Jezero crater's delta scarp, if you remember the progradational deposition, right? So how has it helped to scientists to actually reconstruct the paleo environment or paleoclimate?
Yes, let's talk about the history of Zozero crater. Okay, basically, the common understanding is that the crust of Mars is majorly made up of basalt. Okay, the basement rock is basalt. So it was a basaltic crust in the past. Then the impact happened and Jezero crater formed. Okay. So a crater means a depressed area, a depression. So a depressed area, water will flow there. So it became a lake.
Right.
So with two inlet channel in the west and north, and the outlet channel in the east. Okay. So then what happened? Eventually, that Mars, the surface of the Mars, got dried up. So today we can still found some signatures of water, like the polar ice caps, like the in terms of cells. But okay, is there anything
Yeah.
problem with the internet?
No, you are audible and as well as visible. Yeah.
Okay, thank you. So तो फिर हाँ where was I? Yeah. So then to uh, so people have identified such things and reconstructed the paleo environmental and stratigraphic records of the
Mhm.
Jezero crater by the help of orbital data, mainly what is working on Mars, like Omega and Prism instruments by NASA. So
Basically, a aerial photograph, right?
yeah, yeah. Then the Perseverance rover went there
Hmm.
and it collected these photographs and the data. Then people are connecting this data, what is given by the Perseverance rover, with
Hmm.
the known history. I would like to suggest that term, use the term history. What was churned by the rover data? Sorry, the orbital data.
Hmm.
So you mentioned about the photograph of the delta progression also.
Right, right.
Yeah. So in Zozero crater, there is a huge delta sequence on the west. Okay. So these delta, uh, by aerial photographs, it has been identified as delta. And now from the field photographs, it is pinpointed that yes, what we are identifying as delta from photograph. So this all about perspective. Okay.
Hmm.
If you take a photograph of yourself holding the camera up above your head, you will be considered short. Okay.
Right.
Then if
Right.
you place the camera below your waist level, then you will appear very tall. But so if you compare these two images, then you will get an idea about your true height. So it's like that. That is nothing is more correct in science. This is that adding up, piling up information. So uh, now I will add some point to it that Zozero crater, the history has been mentioned and it has been established. Now Perseverance is doing its job to collect samples and looking for biosignatures. Meanwhile, we want to study our very Earth surface to find the similar places. Like this, we are seeing some delta progressional feature there. So people have worked on many deltas on Earth. So we
Yeah.
can relate these images, this photograph from Zozero crater itself to what we get on the Earth to interpret what we are getting there. Okay.
Hmm.
So this is the basics of analog studies. Without
Okay.
practically going them, just we are to interpret by seeing the similar places, similar geology, similar mineralogy in our Earth itself, where we can physically go and physically collect the sample, physically do the field work there.
Hmm. Right, 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 right. So as well as like, what I know about is like, as you already mentioned about these two differences between the aerial photographs as well as the photographs that you see at the ground level. Like it reminds me something like when we actually design a 3D model, right? And when you are actually design a 2D model, and once you flip it, you can actually measure the height and what are the different strata levels, right? So which is very fascinating, as well as like you mentioned about, to actually, we already studied multiple deltas on earth, right? Now it's time to actually understand the same delta, same kind of delta in another planets. So that must be the, what I can say, the origin might be the similar, the processes might be the similar, because like as Jam Hudson like always say, like present is key to the past. Like whatever you study right now is somewhat originated at past, and with the same sort of methods, with the same methods, right? It doesn't matter like what the planetary body is, like, which is very interesting. As well as this brings us to actually consider to actually, क्या हम किसी को एनालॉग साइट बोल सकते हैं, राइट?
Yeah,
This is a very vital point. Like if we can actually understand and comparing the both, what I can say, the structure, right? So it also helped to actually better understand the analog sites and that we actually got this. So like I want you to ask is like, how can we study geology of different planets on earth? Like this is just a one example of it. Like we talked about the delta, like what could be the other examples, and like how can we study, you know the geology of different planets on earth?
yeah. Um, like in our entire world, many analog sites have been identified. Okay, so mainly structure analogs, geomorphological analogs, or mineralogical analogs. I can give you some example. Like in our state of Gujarat in India, so there is a place called Kutch, the region Kutch. It's famous for the run, the Bunny Plains.
Yeah,
Okay,
run of Kutch.
run of Kutch. So there is a place called Matanomat. There
Hmm.
is a famous temple there, Ashapura Mata Temple. So there, a particular mineral, jarosite, has been identified.
Hmm.
So I have already told about the stability field of the minerals.
Hmm. Hmm.
Yeah, this mineral jarosite has very restricted stability field.
Okay.
Okay, so this on Earth they are found in a handful of places, and only in 6 to 7 geological environment. Okay, so suppose they are found in like 100 places all over the earth, and all the 100 places can be categorized into 6 points, matlab, 6 parts. Okay, so but on the surface of the Mars, they are found hugely, like tons of geosite has been found. There is a place called Meridiani Planum.
Hmm.
Okay, the huge plain land on Mars.
Yeah.
So there, the 30% of the surface of Meridiani Planum is made up of jarosite only.
Okay.
And yeah, and another fun fact that in 1987, a scientist named Roger Burns,
Hmm.
he used just mathematics and calculated the occurrence of several hydrous sulfate minerals on Mars. Okay,
With the help of
so
mathematics.
only mathematics, only
Wow.
thermodynamic calculations. Okay,
Okay.
then on in 2004, when the Opportunity rover
Hmm.
identified the presence of mineral jarosite on the Meridiani Planum, he calculated it and in formulated it in 1987, but the mineral was identified in 2004. Okay, this is like seeing the future. You are yourself
Right.
writing that I am saying that this mineral could be found on Mars. Okay, I could say that, but the point is, in 2004, after almost like 20 years, 21 years, I think, people have identified that mineral on
Hmm.
the Meridiani planet. And they term this mineral, the sequence there, after him, is called the Burns Formation. So let me come to the point that the stratigraphy there on the that
Once
Meridiani Planum,
formation. Yeah, meridian.
the Meridiani Planum,
Hmm.
there we get basaltic surface,
Hmm.
then the altered phyllosilicate, the altered basalt sequence, then some the hydrosulfate deposits,
Right.
topped with the aluminium phyllosilicates.
Hmm.
Similar kind of stratigraphy has been found from the Matanmud site.
Oh,
So
okay.
yeah, so not only identification a mineral or a feature can make any area analog. You
Hmm.
have to pinpoint the occurrence so that it is similar. Okay, I could say I am similar to Anuj because we both have two hands, 2 ears, two eyes, but we are not same. So if
Right.
I want someone to be said that similar, that I have to what can I say? What can I do? I can check the genome sequence here also. Is forensic studies, okay,
Right.
to identify a person, missing person. So like that, this is very key point, that how to search for analog sites, how we can say any place this is an analog to some particular situation of different planetary bodies. So this is the important point that we planetary geologists, the analog scientists, which we do in the analog geological processes, they have to keep in mind like that.
Hmm. Hmm, hmm. Right. Like as well as there is one more thing that, like as you already mentioned about, you know, the thing, how do we call it, like the similarities between those planets, like the burn formation, as you already mentioned. So I remember, like, and I really fascinated by that, when the very first time I read one research paper on the burns formation. So that different stratigraphy, it's really fascinating, because you find some hydrated layer, then you at the top you find some alluvial deposits, and even at the same time you find some leaching material as well. Like, I don't know what exactly it is, because I also have to study deep more it, but yes, that was the thing. So I astonished when you said about that you have find same kind of things in the state of Gujarat, right?
Yeah.
Which is very interesting. So, so it's like wow. So this brings us to, to understand what sort of analogy that you are actually looking for, right? It can be the morphology if you are looking for that particular thing. It can be the origin analogy if you are looking for the origin, or you can go, you can go more further into details. Like, maybe you can study the mineralogy, like, which is like pretty much a more detailed analogy, right? So this is a very fantastic and very nice that analogy that you put. So for the same, I like actually want to ask one more thing, like, what are the basic criterias that we actually have to fulfill for a site to be recognized at a planetary analog site?
Um, I think I already answered part of it in my
Yeah,
previous
part of it, right.
answering your previous question. Like first, I talked about the identification part of an analog place. Then, what you have to do is to study the place, and you have to say definitively as their about their history of why this has formed here. Okay, so we do analog studies to answer the question about different planets. Okay, so this is nothing but a terrestrial geology, conventional geology, what we do, what the research we do, but we just connect them for different planets.
Right.
Okay. Uh, like there is a crater in Maharashtra, the Lonar crater. It is the most famous and well preserved crater in India. So the Lonar crater, for the Lonar crater, the substrated basalt.
Yeah.
Okay, so it is a simple crater on basaltic surface.
Hmm.
So this Lonar crater can be, and also it is used as an analog to the craters of Moon and Mars,
Hmm.
because majorly the composition of the Moon is majorly anorthosite and basalts, and I mentioned the primary composition of the Martian crust is majorly basalt. So the Lonar crater has been identified as a Martian analog,
Right.
and people have studied the structure, the mineralogical parameters, what changes in the basalt state due to the impact, the
Hmm.
hydrothermal alteration processes there due to the impact process, and then everything has been well documented. Hmm. And the answer, and they can be used, they are using these answers, these results for different planets to
Yeah.
answer the occurrence of the particular minerals or particular structure on the Moon and Mars. And just for giving you an example to answer that question.
Yeah. So that's why we need actually to first recognize the, planetary sites, because we are also like planning for one of the expedition program. That's why we actually needed to first spot and to identify few, like whether they are actually following few criterias or not to be called as, the planetary site or not, analog site or not. So like at the same time, like once we are already spotted, spotted an analog site, like okay, this is an analog site. So what could be the, like, astrobiological aspect that we can put, like if that particular place is planetary analog site, so like how it would be beneficiated to astrobiological research if you want to do.
Um, Before starting analog study about astrobiology, I can mention a major leap in our scientific community that people have grown plants on the lunar soil.
Mm,
Okay, you probably heard about the news. It is all over the news that people have germinated a seed, some seed on the lunar soil. So
right.
this is a part of astrobiological research
Yeah.
also. Like, and another kind of astrological research is going on the ICES, the International Space Station. So they are trying to germinate some seeds on the geogravity, the experiments there. But in terms of geology, what we are trying to do, we are trying to identify life on extreme environments,
Mm,
what we call the extremophiles. Why so? Because scientific community has agreed that these extreme environments are the cradle of the life formation process on our earth.
mm,
Okay, so like the hot spring systems,
yeah.
they are the most favorable candidate for the primordial life to occur. So if we characterize these extreme environments geologically and mineralogically and geomorphologically, what we can have, we have a ready reconnaissance to find these kind of places on different planetary bodies.
Mm,
Okay, probably in the next mission when future missions will go, then we could say that okay, this is the possible place to find life.
right.
Like, let's talk about Jezero crater. The Perseverance rover went to Jezero crater. There was several landing sites which have been people have been talking about, but people have choose Jezero crater to be the landing site of Perseverance rover because it hosts the largest known carbonate deposits on Mars.
Mm,
So this carbonate, we connect it with the life. So for biosignature preservation potential, this place is the most important. Like
right.
that, if we can identify the and analyze the extreme environments, like hypersaline lakes, okay, like arid desertic conditions, then we can identify, then it will help us to identify the similar places on different suppose say Mars. Okay.
Right. So like I also want to like invite people's, like if you have any questions now, like, and you want to ask something to Mr. Sarkar, so you can definitely write in the chat section, and after the whole session, then we will definitely take it at one by one. But make sure do ask your questions, because this is the very interesting conversation that is actually going on, because I'm actually enjoying it, right? So anyways, come back to our conversation. As you like already talked about, what are the benefits of, the astrobiological research, that you already talked about multiple sites where actually we can figure it out, some bacterias and all this stuff to study actually the extremophiles, like you mentioned, that like hydrothermal vent. This is pretty much interesting, and I also visited that personally, and I saw at one microbe in the hand, right? And we captured that photograph, and I don't know what exactly that micro or the organism is, but yeah, it is actually surviving in saline as well as a you know thermal condition. So like I was just curious like how they were surviving over that condition. And even when we studied the all these extremophiles, like for example the halophiles, like in that much high saline condition, how they can adapt themselves to survive in that harsh condition, which is a question, right? How they become
Yeah.
so much robust. Like if we actually understand what is the biology and what is the genetics of that microorganism or whatever the organism is living there, so how much benefit that particular thing to survive ourselves in such harsh condition, if in near future we faced because catastrophe from where it's come, we never knows, right? So yeah, so like by mentioning all this thing, like as you at last you mentioned about the the saline condition and the hypersaline condition. So we actually at Spaceonova are organizing an expedition for in India for the first time to identify in Rajasthan as a potential Mars analog site, right? And I must tell you, it is also a hypersaline lake, which we are looking for as a Sambar Lake, right? So there is a like high probability and possibility to find some microbes which are halophilic in nature, as well as the geomorphology of it to gives the more hypersalinity, right? So that's why we actually like considering it as a like, potential Mars analog site. Like can you please let me know how important do you believe such like field works are very important in for the future explorer, like for the future aspiring astrobiologist or the aspiring planetary geologist.
Uh, like you have already mentioned about this Sambar Lake. So
Yeah.
what I know about Sambar Lake, it is the largest hypersaline inland lake in the
Right.
country. Okay, so it has several inlet channels,
Hmm.
and a lake mainly becomes hypersaline, inland lake, because of the high evaporation rate than the water intake to the system. Okay, so in these conditions, some particular organisms can thrive. They're not the bigger organisms or the higher grade organisms. I'm talking about life here in microbial forms. Okay, as you have mentioned, they are called the halophiles.
Right.
They're extremophiles, support, but they are typically called the halophiles. So these halophilic organisms, you can study them biologically. So as I know about this expedition program, it will be a joint venture between geologists and biologists, both expert from experts from both the field, geology and biology will be there to
Right.
guide the students. So
Exactly.
yeah, so it will be a good thing that as a geologist we visit some field work, and we see that here if we are carrying out astrobiological field work, then we face some problem of collecting samples, because collecting samples in geology and collecting samples in biology, they are completely different. Both are
Yep.
completely.
Yeah,
So this
completely different.
multidisciplinary nature of this field expedition will give you the big leap. Okay, a good starting point for the young students who will be attending there. So let us talk about the scientific part. What can people do? That these hypersaline lakes, because of the evaporation, this makes some structures. Okay,
Hmm.
like cracks.
Right, right,
These
right.
structures, and their mineralogy. They can be mm, researched and they can be identified, because I already said that except from Earth, the other planetary bodies, the terrestrial ones, they're this well, majorly for Mars sake. So as it is dried up and the atmosphere is very thin, so hypersaline lake condition has been found on several places on Mars.
Right.
So we can connect these to those places there, and also like these microbial organisms, they can turn their colors, switch their colors, so they can
Right.
change the whole color of the water. In Lunar Lake it also does. There are several papers of the changing color of Lunar Lake. This is also saline lake there. So this in Sambar Lake too, the changing color is a pretty much fascinating phenomenon.
Yeah,
And
even like when we see the aerial photograph of the Samba Lake, you can see actually the palettes of color, right?
yeah,
At that
this
places,
color
like
changing, as my knowledge goes, is due to the microbial, the presence of the microbes there,
definitely,
and it
definitely.
is like a shield from the sunlight,
Hmm.
because as they try to protect from the UV rays. So these things, this genetical modification, what can cause the sunlight, the UV rays to block, it can be used for our by humans for
Yeah.
future Mars exploration, future moon exploration, because there is no atmosphere at all. Not forget about talking about ozone layer. So this cosmic rays, the UV rays, will hit to the direct to our skin surface. I'm not suggesting that people will walk bare skinned. There will be some protective shield like the what astronauts wear,
Right.
but by seeing these kind of things, it will help us to research on that purpose too. And also another thing, there are microbial mats. So these microbial mats, they form us good kind of structures. Okay, and these structures can be preserved over centuries and millions of years.
Right. Right.
So like in ancient Mars, like I have to mention here that the Sambar Lake, they're not an analog for modern day Mars. This is a analog. This can be proved to be an analog for the ancient Mars. So
Definitely.
if any microbial life or this life in the form of the mat kind of thing that can
Mhm.
happen, or any algal life is present on any surface, that there's this like the stromatolite what we find on the earth's surface. So the structures, if we identify the structures only on a different planetary body, that will help us to identify the places to find biosignatures.
Wow, wow, that's pretty much interesting and pretty much fascinating to actually hear about this particular thing, because whenever we are considering these places as the analog site for the first time, you might ask like why exactly it is potential to be the ancient Mars, at least if we are saying. So yeah, these are the few reasons that actually you can look for and you can actually consider, and you can actually propose your own brainstorm yourself to dig it out some more research aspect and the problem statement that you actually want to solve it at that particular place, right? Which is like I consider very nice, and definitely we also have to look for like for the same. In our like Mars expedition, we already like identified few of the aspects of problem statement that we are actually solving, right? So for that we are actually inviting students all over India as well. Like if you want to contribute on that problem statement, we actually welcome you and you can register for our MASE program. At the same time, if you have your own proposal for the same site, like because whatever my understanding is, my understanding from the geological perspective, the biological guy have the different perspective for the same place, right? So that's why we open it for the like people all over the India. Like if you have your own proposal for the same site and you want to study that particular thing, you can definitely propose us, and we'll mentor you for the same. We have like some dedicated astrobiology change maker, as well as dedicated department to mentor you for the same. So yes, guys, you can definitely check out that as well. So at the same time, I like want your opinion, like what would you recommendation to the Mars Analog Site Expedition participation in order to them to get the most out of this experience.
Um, like it's a great opportunity, guys. So just grab for it. So just let's forget about astrobiology and all these big things.
Hmm.
uh, you will be able to go to a geological as well as biological field work. Okay, Anuj, I don't remember that in my student days, when I was pursuing geology, uh, rather in a bachelor degree or master degree, I haven't went for a multidisciplinary field.
Hmm.
So this is quite a new thing that the students will enjoy and they
Yeah.
can learn. And there is no boundary of knowledge, so you can learn every day from everything everywhere. And when we go to a field in our geology, there is a common saying that when you are going to field, you are doing 90% of the science there.
Hmm.
Okay, so I would like to suggest them to join and to try to understand what the mm, change makers are saying to them, what they are teaching to them, and ask every questions. No
Right.
question is bad questions. So even the bad questions are can help. Okay, we all feel shy to ask questions.
Right.
I don't think in comment section anybody asks questions or not, because in these sessions or in field works in classes too, people don't ask questions. Okay, they try to be shy that I will ask these questions and other students will laugh at me. Let them laugh, but your question will be answered by the teacher. Teacher
Right.
cannot laugh at you. Teacher won't laugh at you. He or
Hmm.
she will answer your questions, and that will be the main point of the teaching. So you, when you in our ancient India, people used to teach and get taught by asking questions after questions. Okay, so this is the main thing. Just guys, go for it. Best of luck for the
Yeah,
field work.
and that's why we are actually asking, like, if you have any question, you can please write down in the chat section, and we'll definitely answer your all of the questions. Because like the very famous saying, right, like the craziest question or the lamest questions become the greatest idea, right?
Yeah,
So
yeah.
you don't know like why the your question might be a problem statement itself, right? So don't hesitate to
Uh,
ask. You can
yes.
definitely write on chat box and we'll cater your question as well. Now here we are at the end of our today's conversation. So like after all these things, after all that we just have like talked about, all the planetary geology, the analog sites, the impact crater that we talked about, and the Perseverance rover. We went from Earth to space, then again back to Earth, right? So, like, I want to know, like, which book or movie, like, best motivates you to achieve your own dreams?
Hey, it's a tough question for me. Uh, because the people who know me, they know that I am a voracious reader. Okay. I there is a very great saying, that very famous saying, like people who reads the most. I can read the cover packages. Okay, when you go to the Kirana store, it will give something to your small packet. I can read them too. So I read here and there and every book. But um, if you ask me that which book or movie motivated me, then I could suggest some books to the young minds.
Yeah.
What I think they can motivate themselves, because I when I read those books or watched this movie, I was like in started my career in geology. Okay, I studies in geology. So I found those books and I thought that yes, those books I wanted in 5 years back. Then there won't be any dilemma to taking the in taking the subject. Okay, when I took geology, I was a bit shaky that I don't know. We don't know about the subject geology and this planetary science, astrobiology as well. So, but eventually I started reading, started studying geology, and found some very good books about it. Like in first book I want to mention, it is in Bengali, hmm, my mother
Mhm.
tongue. This is called Antarctica. I think the English translation is available, written by Sudipta Sengupta. She was one of the first women explorer from India went to Antarctica in the second Indian Antarctic expedition.
Mhm.
And very lucidly, she had written about the basics of geology and basics of Antarctic expedition. And definitely, any people who want to study geology, they could find the book useful to get motivated.
Right.
And for the space exploration purpose, there is a famous show called Cosmos. Okay,
Right.
I it was primarily by Carl Sagan, and then the famous astronomer Neil deGrasse Tyson just rebuilt it, the same show with modern day technologies and VFX and all. Both of them are mm, pretty much awesome. Okay, they will answer the basics questions of universe, and they will curate the nurture the curiosity to your mind to know more about space, our universe, and our being. When, why we are here, from when we are here, how we are here, and last question, why we are here.
Right. Exactly. Wow, wow, what a fantastic things that you just mentioned at last. Yes, and I believe that these two guys, like the host of Cosmos, like almost inspire, like almost all space enthusiasts, like they inspired. So yeah. Anyway, so
Anuj,
yeah,
I can add one more thing. So, we both mentioned about Carl Sagan.
you're
He has
right.
a famous paper, okay,
Mhm.
published in 1990s. So, in that it was nothing that when the Galileo shuttle was going outside our solar system,
Mhm.
it took a leap around the Jupiter. Okay, from there, it took the image of sun.
Oh,
Hey,
right,
sorry,
right.
from to image of Earth. Okay,
Yeah,
the famous image, the pale blue dot.
the pale blue dot,
What
right.
he done, he did the spectroscopic analysis of the pale blue dot. That is
Mm-hmm.
nothing but our Earth. Okay, so he identified the signatures of carbon and methanes,
Mm-hmm.
the basic hydrocarbons, and published a paper. and said that if you want to study or identify life in any exoplanet, this is your analog.
Oh wow,
So,
that's
so
interesting.
this is science. So we
Yeah.
don't have to think any views, think and this and that and technology and advancement. Nothing. Just think out of the box.
Hmm. Right. Okay, okay, okay. So like we have one question from our audience, and this question is from Rahul. And Rahul asked, like Mars and Moon can be the better place for colony. Like if you want to colonize once a celestial body, what could be the potential one?
Look, people have mastered all over the art, and I would rather add that people have a colony on the space in terms of our ISIS, International Space Station. People are staying there. So, in near or distant future, it is no talking of science fiction that it cannot be done. People can uh, colonize moon surface of moon and Mars, but uh, it is my understanding goes by, but my heart says that don't go for it. We have enough place in on our earth, so let's make a better place here.
Right, right. So it is first like first make our home better. Again,
Yeah,
again, like we just talked about the Dr. Neil deGrasse Tyson. So he once said in one interview like we are humans and we have the tendency to build a like big structure and all have the capabilities to turn Mars into Earth. So we also have the same capabilities to turn Earth back into Earth, right?
yeah,
Which is a
nicely said.
mind-blowing thing, right? Like we first have to secure our own planet, then because as much as we can sustain over here, then we have as much as time to think more and improve ourselves to construct a better infrastructure for that places, right?
Yeah,
So which is very very nice and wow, I really enjoyed the conversation that we have like today. It was like very informative as well. So like guys, if you have any questions, you can definitely ask, and if not that, thank you so much for joining. And don't worry, guys. Again, we'll come back with some another session and with another person, right? So thank you so much for joining in and stay tuned with us. So bye bye. Have a good day.
thank you.